Professor Bob Young back at you here, and in this third and final video on rationalizing the denominator, and yes, I am going to get to its counterpart, rationalizing the numerator, if anyone ever asks you to do it. We are even going to go a little deeper. Now, what if some scumbucket dirtbag lowlife gave you more than one item in the fraction in the bottom? What if they gave you a binomial denominator? So this is called rationalizing the denominator, having two terms. And what we're going to do is multiply numerator and denominator of the fraction by the conjugate of the denominator. So first, we're going to talk about what is a conjugate, Young. Every binomial has one. So I'm going to list conjugates over here. So I'm going to give you, let's say, a binomial x plus 3. Its conjugate counterpart over here would be x minus 3. Let's try another one. 3y plus 1's conjugate would be 3y minus 1, and so forth. So what really helps us here, when we have two terms in the denominator, if we multiply by the conjugate, which of 2 plus the square root of 7 would be 2 minus the square root of 7. So everything stays the same except that middle sign. And remember, whatever you do to the bottom, you must do to the top. And ladies and gentlemen, what do we have here? We have our friend FOIL back, and this was on the multiplying radicals. So some more examples here. And if we didn't use the conjugate, we would not get rid of all radicals in the bottom. If we just multiplied this by the square root of 7 itself, like we did in some of the other episodes, we would get the square root would move to the 2, and we would still have a square root in the bottom. So I told you there was a time way back where conjugates would be your friends, and here them. All right? So 2 times 2 foiling, 4. The outside two terms would be minus 2 times the square root of 7. The inside two terms would be plus 2 times the square root of 7. Good exam review here. And notice when you FOIL conjugates, FOIL goes to Florida, if y'all remember. And then the square root of 7 times the square root of 7 would be minus 7. All right, because remember, if you take those last two terms, any square root times itself comes clean, and that sign is a minus. Be careful. All right, now what does that give us when we do that? Well, 4 minus 7 in the bottom, and I'll go ahead and circle the wagons here, okay? Those are going out, gives us what? Minus 3 here, okay? Now, notice I didn't distribute that 6 through the top. Now, a lot of instructors may have done that first, but I don't do it. I tell students to wait to see what this bottom number is before you distribute that 6 through, because if you would have distributed it through, you would not have seen, wait a doggone minute here, 3 goes into 6, or negative 3, I'm sorry, goes into 6. What? A negative 2 times, you've got a chop, chop, in there. So there is the answer Math Excel will look for distributing the negative 2 through. The first example will be negative 4 plus 2 times the square root of 7. Now, of course, you could put all over 1, but anything over 1 itself. So notice we got the radicals out of the denominator. All right, next example here. We're going to multiply both top and bottom by the conjugate of 2 times the square root of x minus the square root of y. That would be 2 times the square root of x what? Plus the square root of y. And again, whatever you do to the bottom, you must do to the top. Okay. Now, if you remember, whenever you multiply something by conjugates, FOIL goes to Florida. Well, that must be back in chapter 5. We were doing things like that, multiplying conjugates. And then we're going to have, and be careful here, this 2 times the square root of x, 2 times the square root of x. 2 times 2 is 4. The square root times the square root, 1x comes out. The y is the square root of y times the square root of y. One's positive, one negative. This gives you minus the square root of y squared. Or, ladies and gentlemen, we have gotten rid of those radicals in the bottom using the conjugate. It is rationalized. Now here, we are going to distribute this through, since I don't think there's anything that's going to affect it in the denominator. So 2 times the square root of a times 2 times the square root of x. 2 times 2 is 4. times the square root of x or ax. So do you see these beautiful examples Young's giving you? He's doing numbers with numbers and roots with roots again, just to make sure we got this radical concept down. Plus distributing that 2 times the square root of a, we're going to get 2 times the square root of ay. And there's your answer. All right, last slide here, last graphic. Or, of course, we could also rationalize what's called the numerator. All right, so let's just do a few basic examples here. You don't see this as much, but you can get the radicals out of the top if you wanted. So in this first example, we're going to use the quotient rule and break apart the square root of 5 over the square root of 3. Now, if we want to get the radical out of the top, remember, there's a square root here. That's a little 2. There's a 1. We would multiply, since we need 2 of each item, by that same square root. And everything is already simplified in this first example, so I tried to keep this first one simple. And again, the square root of 5 times the square root of 5 would be the square root of 5 squared, or the square root of 25. So, aha, we have gotten the radical out of the numerator. And what would the denominator be? Oh, the radical's left down there now. Root times root gives you a root. So you could do it the reverse process too. I hope that didn't just blow anyone's mind there. And for the last example here, and we will conclude this section, I know it's been fun for y'all, we can actually see that this simplifies first. So we can say, well, we've got a cube root here. We've got some x's coming out of there first. So always simplify these things first. And that will give us 3 goes into 5, 1x comes out of the top, times the cube root of what is left, 3x squared. And I'll put a 1 on that 3 there, all over 10. Now, if we want to get that remaining radical out of the numerator, how many more 3's and how many more x's are we going to need? And if you don't see it by now, unlike your lecture class professor, you can rewind and watch it over and over again and take better and better notes, and it'll sink in, hopefully. Okay, we need 2 more 3's to get 3, because that's a cube root, and we need 1 more x. And if you do it to the bottom, do it to the top too. Or if you do it to the top, do it to the bottom. They're fractions, silly students. Young, you're not making any sense. Yeah, I am. I'm just, again, still waking up here, having my coffee. So you're going to get the cube root of 3 cubed x cubed here. So 1 3 and 1x comes out. Now be careful, I'm going back to the orange like I did before. This x was already out when we simplified, times this 3x there. So the final answer, and we'll be done with this section, will be 3x squared over 10 times the cube root of 9x. Young, where'd you get 9? Where'd you get 9? Remember, they won't leave that 3 squared there. So we have taken the radical out of the top and put it in the bottom. You can do that, or you could take the radical out of the bottom and put it in the top like we were before, using these same concepts. All right. Start pounding that homework now, and both if you're a lecture student in the textbooks, if you're a hybrid student or online student using the software. Professor Bob Young signing off. Have a great one.